Okay, so for this video we're going to review what a bounce heights are and how to solve a problem with it. So Dylan drops the ball from an initial height of 450 meters. So let's draw our ball. Okay. And here's the ground. So he's going to drop this ball, and this height from here to here is 450 meters, okay? The ball is going to drop, and it's going to bounce back up, and it's going to only go this high. So it's the ball. But this height is 337.5 meters. And so we can ask ourselves a couple questions. So, question 1, what's the height going to be for the second bounce? So the thing about dropping balls and bounce heights is that the heights represent a geometric sequence. Okay, so bounce heights, I want to think geometric. Okay, so if you need a review of geometric sequences, go back and watch the video on sequences. So we got to figure out, since geometric sequences have a multiplier, we got to figure out what that is. So to do that, I'm going to take the second height, so 335.7, and I'm going to divide that by the original height. I'm going to find out what that is. So we're going to go 337.5 divided by 450. That equals 0.75. So that is my multiplier. And so to get the second bounce, so if this ball, if you've ever bounced a tennis ball, it bounces and bounces and bounces, keeps getting smaller, right? So to figure out how many meters high the second bounce would be, I'm going to find 337.5 and multiply that by 0.75. So I'm going to times 337.5 times 0.75, and I get 253 point, I'm going to round here, 1 meters. Okay, that's great. So how about on the fourth bounce? Now, we could keep doing this forever and forever and forever, but I don't want to have to keep multiplying by 0.75 each time. So let's do a shortcut. Let's create an equation. So geometric sequences have this model. B, remember, is the multiplier, and A is the zeroth term. So if I look at the heights as the heights here as terms of sequence, this would be the first term, that would be the second term. So the zeroth term would be, well, what if the tennis ball was actually dropped from a higher height and this rebound height was 450 meters? So how would I figure that out? Well, to go from one term to the next, I multiply by 0.75. But to go backwards, I divide. So if I take 450, divide that by 0.75, that'll give me 600. So the zero term would be 600. So the ball would be dropped from way up here at 600 meters for it to have a first rebound height of 450. So A is this. So I have an equation at y. So that's not, we don't use y. We use t of n, I'm sorry. So t of n is going to be equal to 600 times 0.75 to the n. And n is the number of the bounces. So the fourth bounce, I want to find out what t of 4 is. So I go 600 times 0.75 to the fourth. So I get 600 times 0.75 to the fourth power. And I'm going to round this, and I get approximately 189.8 meters. And so the third question has, how about the nth bounce? Well, all that is asking me for is to come up with a model for calculating the height of any bounce. So that would be my sequence rule I generated above.